All right, welcome back. Sorry about the interruption. Let's kind of keep working through example 4 here and taking a look at what it's trying to show us. So they're basically giving us this situation that's happening here. They're giving us the fact that BE is perpendicular to DF based off of that right angle. They're giving us the fact that AEB, this little red tab here, that angle is equivalent to CEB, that little red tab there. That shows that us that those two angles are equivalent to each other. And then these two lines are parallel. AC and DF are parallel because of those two little red arrows. That indicates things being parallel. So given that information, they want you to find BAE and BCE. They want you to prove that they're congruent. That's what that line means, or the symbol, the equation, the equal sign with the little tilde above it, the little squiggly line, that's congruent. So some of these things and these reasons, after walking through that last example, I realized some of this information is coming from a previous lesson that we skipped in chapter 1. So bear with me. We're going to talk through all of this stuff that's here, and I'll kind of explain what we're going to do with these types of problems here in a little bit. So you always start off these 2-column proofs with the givens. You always list the givens. I don't know what the reason is, but you always want to begin with the given information. There's not always just one piece of given information. Sometimes there's 2 or 3 things, so you'll have to list everything out. So everything that's given, make sure you're writing down here. So line AC is parallel to line DF. Again, that was given. Line BE is perpendicular to line DF. Again, that's given. And technically, I would have written angle AEB is congruent to angle CEB, and that's given as well at the top. They put it down here a little bit, and the reason why is because they didn't need to preface this information right there at the start. They only talked about the information that was given that was going to kind of build their case over the next couple steps. And then once they needed that information, then they showed it to be given, and then they finished the problem off. But typically, at least the way I was taught in college math, was all your givens come up first. So once they tell you that those 2 lines are parallel and those 2 lines are perpendicular, what you can say is that angle BED, so that is this angle right here, that big right angle, okay, BED, is equivalent to angle BEF, which is going to be the right angle on the right side, BEF. So how do you know that? Because that's the definition of perpendicular. If BEF on the right side forms a 90-degree angle, well, then on the left side, BED, that also has to be a right angle. Remember, a line, this line DF, if I add up all these angles together to form a line, that adds up to 180. So if I tell you the right half is 90 degrees, well, the left half has to be 90 degrees. There's only 90 degrees left. So I know that BED is also 90 degrees because of that line being perpendicular. Then they state that the measure of angle BED equals the measure of angle BEF, which we just talked about. They're both right angles because that line BE is perpendicular to DF. It's coming straight up from it. So those angles have to be equivalent to each other because that's the definition of a right angle. Right angles are 90 degrees. Then they're saying that the measure of angle AED plus the measure of angle AEB, so AED, and then AEB. So what they're talking about here is this right angle right there. So starting from the bottom, it kind of rotates all the way straight up. Okay, so that angle, those 2 angles together right here, those 2 angles add up to 90 degrees, which is what they're stating. AED plus AEB equals 90 degrees. Same thing with the right side. If I state that these 2 angles together are 90 degrees, right? If I add those 2 angles up, they're going to be equal to that 90-degree total angle. So CEF, CEF, so that's this bottom angle here, plus CEB, CEB, so that's this angle right here. If I add those together, that's going to add up to 90 degrees. And then the reason they're saying that, the reason why I can say that those two angles add up together to be 90 degrees is because there's a postulate. And when I say postulate, I just mean a rule. Same thing with theorems, right? This says congruent complements theorem. This is a postulate. Theorem and postulates are basically just rules that math have. We got to be difficult and make up new words just to represent a rule. I wish they could just say angle addition rule, congruent complements rule, but just know that it's a rule. It's a fact that happens in math. So the angle addition postulate just states that if I take a piece of a larger angle and I add it to the other piece of the larger angle, it's going to equal the larger angle. Okay. Now they're getting back into that given that they said at the top, the third given. AEB is congruent to CEB, so that's a fact, that's given. You don't have to prove that. Now they're going to move into angle AED is congruent to angle CEF. So AED, so that's this one right here, AED, that's talking about this angle right there, is congruent to CEF. So CEF. So that's talking about this angle right here. So they're stating that because of the congruent complements theorem. They're complementary angles. We kind of talked about complementary angles a little bit ago. These are complementary angles off of basically two transversals. There's one transversal, there's a second transversal. So there's a rule back in, I think, lesson 1.5, 1.6, something like that, one of those ones we skipped, that said angles in this type of situation are going to be congruent to each other. They're equal to each other. Then angle BAE is congruent to AED. So let me kind of clean myself up here. BAE, so that's talking about this angle right here, is congruent to AED. So AED, that's this angle right there. And we talked about this a little bit ago. These are the alternating interior angles, right? This is my transversal line. So these are on opposite sides of the transversal, that angle right there and this angle right here. So that's alternating. And then interior because they lie on the inside of those parallel lines. So I know that that angle is equal to that angle because of opposite interior angles. Or alternating interior angles. And then same thing with BCE and CEF. So let me clean this up again. BCE, so that's talking about this angle right here. And then CEF, so that's talking about this angle right here. So those two angles, again, alternating sides of that transversal, and then they're on the inside of the two parallel lines. So I know that those two angles are equivalent, they're equal, they're congruent because of that rule, right? Again, don't worry about postulates and theorems and stuff like that. This is a short way to say theorem. Postulate is just written out. It just means a rule. So the alternate interior angles rule. And then the last thing, which is what you should be trying to prove, that should always be the last thing in your proof, that angle BAE is congruent to BCE. And if I remember, that's talking about this angle and this angle right here. And the reason why that's true is because of a proof or a rule that they talked about again in a lesson that we skipped a while ago. So don't think you missed information. We skipped this lesson. It's called the transitive property of congruence. Okay, so because of that rule, those two angles are equal. All right. Example 5. The white trim shown for the wall of a barn should be constructed so that AC is parallel to EG. So again, kind of look at your picture, figure out what they're talking about. AC is this part of the barn right there. So the right side of the roof. And then that's going to be parallel to EG. So that's this part right here underneath my pencil. Those two lines are parallel. JA is parallel to HB. So JA is the top left part of that barn, the roof. And then HB is right there underneath my pencil. And JC is parallel to KG. So JC is kind of the belt line, right? And then KD, KG is the bottom, like the base of that. So JC is parallel to KG. What should the measure of angle 1 and measure of angle 3 be? So knowing all of that information, all those parallel, there's transversals here that are cutting across parallels. There's lots of information that you can pull from this. They want to know what measure of angle 1 and measure of angle 3 are. So there's angle 1, there's angle 3. So the hard part of this is to kind of remember all these properties that we talked about, all these rules that we talked about so far in this chapter back on the previous pages. Let's just kind of flip back and let me just point them out real quick. So nothing on page 71. There was this postulate, the same side interior angles postulate. Theorem 2-1, the alternate interior angles theorem. Again, don't get caught up with postulate and theorem. They're just rules, okay? Just think of them as rules. Theorem 2-2, corresponding angles theorem. Alternate exterior angles theorem is theorem 2-3. So those 4 rules, it looks like what we essentially have looked at so far. And those 4 rules are also kind of listed at the top of page 75 in that concept summary. So this is a good place to maybe take down in your notes if you're writing notes, or just go back and reference when you're doing practice problems. So example 5, those are all those relationships at the top of page 75. So using all of that information, you can pull, you can figure out what angle 1 and angle 3 are. So what they're saying is by the same side interior angles postulate, which if you go over here to the top of page 75, it's right here. So same side, that means the same side of the transversal. They're both on the right side. Interior means on the inside of the parallel lines. Because of that, you know that the measure of angle 1 plus 68 is 180. So let's take a look at what they're talking about here. I wish I would have printed this off so I can write on this, but hopefully you can follow along. That this angle right here, the measure of angle 1, plus this angle right here, right? Those two angles, these 2 angles are going to add up to 180, right? That's that same side interior angles postulate. So I know that if I add angle 1 to 68 degrees, it's going to equal 180. So you could see right here, they kind of start doing some math. 180 minus 68 is 112. So right now, I know that angle 1 is 112. Because if both of these angles add up to 180, 112 plus 68 is 180 degrees. Okay. And then by the corresponding angles theorem, which is over here, right below the same side interior, this is saying that corresponding angles are equivalent or they're congruent. So for example, just to kind of reiterate what we talked about, angle 1 and angle 2 are exactly the same. This corner right here and this corner right here are equivalent. So if I said, hey, this corner right here is 38 degrees, well, I know automatically that this corner is 38 degrees. I know that this is equivalent to this, and I know that this is congruent with this. You'll notice I'll say congruent or equivalent or equal. They all mean the same thing, okay? So this is that corresponding angles theorem that says all that all of those are congruent to each other. So let's go look at what they're talking about here. Corresponding angles theorem, angle EAB is congruent to angle 2. So let's find that. EAB. So that's this angle right here, that 68 degree angle that they're talking about. That's going to be congruent with angle 2. So you might be thinking, well, how is that possible? Like that doesn't look the same as this right here, right? And you're right. I mean, it doesn't look exactly the same, but let me draw you a quick sketch. I'm a visual person, so when I sketch things out, that makes a lot more sense to me. So if I sketch this barn out, and I'm going to use pen here to sketch this out. And this is gonna be rough, so just kind of use your imagination with me. They're saying, let me go ahead and finish this up. That, this, and this ish, right? It looks pretty close. So they're saying that this right here is 68 degrees, and they're saying that angle 2 is congruent. Okay, I'm going to zoom in here. Okay, so here's the picture of the barn. There's 68 degrees at that angle, EAB. So this is E, this is A, this is B, and then this is angle 2. They're saying that that's equivalent. So watch this. If I extend these lines a little bit, you're going to see the same picture that you're seeing right above my crappy sketch. You're going to see this right here, okay? So here is this line extended out, okay? And then here is that transversal, okay? So these are my parallel lines. That's my transversal. And take a look. Here are those transversal lines that are cutting across those parallel lines, okay? These lines are also parallel. So I can state, I'll put 2 arrows on those. So that way you can tell that those are parallel. There's a lot of relationships here with all these lines. But the ones that this is concerned about is this line right here. These right here. So these parallel lines. And this is my transversal. Okay? So kind of keep that in mind. Here's my parallel lines. Here's my transversal. These are those corresponding angles that are dealing with those parallel lines and that transversal. So it's kind of hard to visually expand all these lines and to kind of, include everything that's happening here. So you really have to do your best to maybe either sketch out a picture or just pull the information you want, right? In this case, instead of having the whole barn, this is what I want. Let me read through that. Let me do this over here so you could see it. I'm off my screen here. So this is what I want. And then there's my transversal. Okay. So there's my lines. There's my transversal. And they're saying that these two are equivalent because they're corresponding angles. Again, visually, it's really hard to do that. So do your best to kind of redraw it and just include the information that you really need. Okay. There's the top of the barn. There's that angle 2. Just do your best. Okay. So they're saying that those two, that EAB is congruent to angle 2, and that angle 2 is congruent to angle 3. So angle 3 must be congruent to EAB. So let's take a look at this. So EAB and angle 2, we just talked about that. So 68 and angle 2, those are equivalent. But we're looking for angle 3, so we need to include that in this problem that we're doing. So here is a parallel line, right? Here is a parallel line. There's my transversal to those two. There's another parallel line, right? There's lots of relationships that are happening here. So you're going to have to pick the parallel line and the transversal that gives you the information you're looking for. In this case, it's these two right here. So here's my parallel line. There's my parallel line. So these two right here are parallel. There's my transversal. And that's going to give me that angle 2 is congruent to angle 3. Okay? Lots of stuff to kind of weed through and pick through, right? You basically have 3 different options for parallel lines, and you have a bunch of options for transversals. So you have to kind of weed through it and pick the parallel lines and the transversal that include the piece of the problem you're looking to solve. All right. So concept summary, that is on top of page 75. There is all your rules. Again, don't get caught up with postulates and theorems. Just think of them as rules that show different angles when you're dealing with the pair of parallel lines and a transversal are congruent to each other. Or they could be supplementary, right? We talked about that as well, like 1 and 2 right here. Those are supplementary. They add up to 180. So let's go ahead and start going through 15 through 22. Okay. So I just kind of wrote out some papers just to kind of make the problems go a little bit smoother, so they were kind of ready to go. Number 15, identify a pair of angles for each type. So like we said, there was 4 rules we talked about. Same side interior. So those are the ones we want to identify. Same side interior. So for 15, I'm going to use red. So for 15, I'm going to use red pen. Same side interior. Remember what they talked about here. Same side, that's talking about your transversal. So it has to be on the same side of the transversal. And interior is talking about the inside of your lines. One thing that's a little weird with this question is that these lines aren't parallel. I don't know if that was a mistake that they did when they were talking about this. Technically, they don't have to be parallel, but I feel like all the questions, all the examples were parallel. Even though these 2 lines right here aren't parallel, there's still relationships with same side interiors, corresponding angles, things like that. So that's okay. It's not that big of a deal. So same side interior. This is my transversal. So that's my transversal line. Same side interior. So obviously this piece, hopefully this shows up. This is the interior. And then here is the exterior. Same thing with up here. This is the exterior, right? So above this line here, that's all exterior. Below this line here is all exterior. In between the 2 lines, that's my interior. So let's take a look. Same side interior. So same side, I'm going to talk about the left side first, or this bottom half almost. And then we're only talking about interior angles. So same side interior, that's going to be 2 and 5. Also, the same side interior, that can be the other side of the transversal, so 4 and 7. The next one I'll talk about is 16, and I'll do that in blue. So 16 is saying corresponding angles. So again, corresponding angles, if you forgot, just go back here, take a look. Corresponding angles theorem is just talking about all those different pieces. So this is equal to this. This is equal to this. Okay? This is equal to this. All those different sides, all those different pieces match up. So for corresponding angles here, we would say that there's lots of choices here, right? So you could say 3 and 7. So angle 3 and angle 7. 4 and 8. 1 and 5. 2 and 6. And I think that's it. Corresponding angles. Okay. And then the last one, alternate exterior. Let's do purple. So we'll call this number 17. Purple. Alternate exterior. So alternate sides of your transversal. One's on the left, one's on the right. And then exterior. So that's outside of these 2 lines. So I can say 1 and 8, right? They're on opposite sides of that transversal, and they're on the outside of those 2 lines. So 1 and 8. And then 3 and 6. Kind of getting off my screen here a little bit, sorry. All right. Number 18, which angles are supplementary? Remember, complementary means the angles add up to 90 degrees. Supplementary means that they add up to 180. which angles are supplementary to angle 1, which are congruent. Again, congruent just means equal. Which ones are congruent to angle 1? So just like before, sketch myself a little picture. That way I can draw on it and I'm not drawing on my book. So angle 1 is right here. So we'll do supplementary. We'll do that in green. So angle 1, which angles are supplementary? Which angles will add up to 180 degrees? Well, I know that a line, if I add up all my angles, will add up to 180 degrees. So, right, that forms a line if I add angle 1 and 2. So I know that that's supplementary. Those will add up to 180 degrees. So angle 2 is supplementary. Same thing with the other side if I go this way. Right? If I start with angle 1 and I add angle 3, that forms a straight line. So angle 3 is supplementary. If I add angle 4, those two are vertical angles. Those things are equal. So if angle 1 equals, 130 degrees, then angle 4 will be 130. Those are vertical. They're congruent. They're equal to each other. They're not supplementary. But don't forget, right? This can also corresponding angles, angle 3 and angle 7 are corresponding, right? These things are exactly the same. So I could say angle 1 plus angle 7, that's the same thing because 3 and 7 are equal. So if angle 1 plus angle 3 is supplementary, then angle 1 plus angle 7 must be supplementary. So I'd say angle 7. Same thing with if I go this direction. If I say angle 1 and angle 2 are supplementary because they add up to 180, and then angle 2 and angle 6 are complementary, well, then I could say angle 1 plus angle 6 are supplementary. The other thing it wanted was congruent. So which ones are congruent? Which ones are equivalent? I know that congruent angles, there's vertical angles that are congruent. So remember with vertical angles, you'll have this X that's right there, and then they're always going to be opposite of each other from that X. So I know that angle 4 is congruent because of vertical, they're vertical angles. And then I know also because these are corresponding angles, angle 4 and angle 8, they're the same. So if angle 1 and 4 are equivalent, if they're congruent because they're vertical, well, then it has to be congruent with angle 8 as well. Uh, 19 and 20. 19 and 20. Find each angle measure. So again, using those 4 relationships we talked about, find the measure of angle 1 and the measure of angle 2. So using the 4 things we talked about, how are we going to do this? Well, the first thing that jumps out to me is that 123 degrees right here that they're giving you and angle 1, that those two are what they call alternating interior angles. So here's my transversal. They're on alternating sides of that transversal, and they're on the inside of my parallel lines. Okay, so those are alternating interior angles. Alternating interior angles. So because of that property, I know that they're equivalent. They're the same. So if this is 123, that has to be 123 degrees. So for number 19, the measure of angle 1 is 123 degrees. And then for number 20, we want to find the measure of angle 2. So the other thing that's gonna let me know some information here is that these two things, right, 123 and angle 2, there's a couple ways you can go about this. You know they're on the same side of the transversal. They're on the same side. And you know that they're on the interior of your parallel lines. So same side interiors. So same side interior angles you know that they add up to 180 degrees. Okay? Or you could think about it this way. You know that 1 is 123 degrees, right? You just figured that out. So you know that those two angles, angle 1 and angle 2, are supplementary. They add up to 180. It's still it's basically the same information, but it's just a different way to think about it. It doesn't matter which way you do. So you could use same side interior, which deal with the given in angle 2. You can use that angle 1 plus angle 2 are supplementary. Doesn't matter. You get the same information. So I know that angle 1 and angle 2 added up are supplementary. They're 180 degrees. So all I have to do is do 180 minus the one I already know, 123 degrees, and that gives me 57 degrees. So the measure of angle 2 is 57. Opposite sides of a parallelogram are parallel. Prove the opposite angles of the parallelogram are congruent. So what they're trying to get you to do here is knowing that this side is parallel to that side and that this side is parallel to this side. Prove that the opposite angles are congruent. Prove that this angle equals this angle and that this angle equals this angle. Okay, that's the situation they're setting up for you. But what we're going to do today is we are not going to go through this problem because at the beginning, when I was going through this lesson, I was fully anticipating on doing these. And then once I started thinking about the information that you missed from back in lessons 1.4 through 1.8, specifically this information, let me show you, right? Definition of right angles, transitive property of congruence. Those are things that those lessons covered. And since we skipped those lessons, I don't feel comfortable assigning this to you and just telling you to figure it out, right? So what we're going to do is I wanted to go through those examples at the beginning of the book just to kind of let you know how two-column proofs work, and how you can piece them together. You can slowly piece together your argument by using facts, theorems, postulates, rules, things like that. But I'm not going to expect you to do these problems this week or from here on out because we skipped those lessons that kind of gave you some information you need to answer these questions. So please don't worry about problem number 21. I will make sure that the instructions on our practice problems state that to skip problem number 21. And then problem number 22 is our last problem. This is setting you up with kind of something that's a little hard to maybe visually see, so I tried to break it down with just kind of creating a few shapes. So 3 parallelograms are hinged at each vertex. So there's my first parallelogram, the one that 122 is in. So there's the first one. There's my second one. There's my third one. The third one doesn't give you any information, right? And I don't know if we'll use it or not, but there's nothing inside of it. To create an arm that can extend and collapse for an exploratory spaceship robot, what is the measure of angle 1? Explain how you found your answer. So basically, they are giving you, and what I want you to do is try to envision these 3 parallelograms as those 3 that I just pointed out to you. Okay? So if I'm reading this correctly, that means it's telling me that this is 122 degrees. And I believe that's the top of the second parallelogram is angle 1. Okay, that's the only information they're giving you there. This third parallelogram, I don't know why they included it, but it is what it is, but there's no information in it right now. So what's the measure of angle 1? So let's take a look at this. Lots of different ways you can imagine this. Parallelograms have opposite parallel sides, so you could see there's a lot of pairs of parallel lines. Obviously, then there's a lot of transversals that are cutting across those parallel lines, right? but let's kind of piece together the parallel lines, the pair of parallel lines, and the transversal that's going to help us here. So, and I believe that's going to be this one right here. So what I'm going to do is trace out the pair of parallel lines and the transversal that I want to keep. So I'm going to do this one right here. Obviously my line drawing sucks, right? And then this one right here is my transversal. Okay, so now with that highlighted, hopefully it kind of zooms you in on what information you should be focusing on, okay? You could probably pick another set of parallel lines and another transversal, things like that, and you're more than welcome to, but this is just the one way that I do it. I know that that supplementary angles add up to 180 degrees, right? So I know that if I add this angle here and this angle here, right? Those two have to add up to 180. So let's actually just use X there, because we don't know it. So if I take this first angle, 122 degrees, and I add it to X, that has to add up to 180 degrees because those two angles are supplementary. So if I just do a little bit of math, I can figure out that X equals 58 degrees. Now you might be thinking, well, we weren't trying to find X, right? But what we're doing is we're taking a step or two before we can actually solve for 1. So I know that this angle is 122. I know that this angle is 58 degrees. Well, what do we know about alternate interior angles, right? What do we know about them? We know that they're congruent. So we know that this angle here and this angle here, right? They're on the interior side. They're inside those two parallel lines. And then they're on opposite sides of that transversal, alternating sides. So alternate interior angles are congruent. So I know if this is 58 degrees, angle 1 has to be 58 degrees. It's got to be. So these relationships that this lesson is talking about, and I'm going to flip back and show you, right there at the top of page 75 are key. They're crucial. You got to make sure that you understand when you have a set of lines and a transversal, are which angles are going to be congruent to each other. They're going to be equal to each other. Which angles are going to be supplementary, right? Things like that are really important from this lesson.